In this section, we're going to look at how water is used across the U.S. and globally as well. This pie chart shows the water use in the United States. This is from the same data that you looked at in class on national water use. If you start at the top of the graph with section where it's labeled 11, that corresponds over here with where it says public supply, and then goes clockwise down this list. So you see that we currently use 11% of our water with public supply, domestic, a large percentage, 31% irrigation, smaller percentages for aquaculture, industry, and mining, and the biggest share of our water use in the U.S. goes towards thermoelectric power. If you're wondering what public supply means, that means water that is supplied by a company or a municipality for what are considered domestic, industrial, and commercial uses. These might be for individual family homes, residential, for businesses, restaurants, and even some industrial settings where a corporation that makes products may need to purchase water from a water company. Domestic is only 1%. This would be indoor and outdoor residential use, and these would be people who do not get their water from a corporation. So these are more likely to be rural customers or rural citizens who are responsible for drilling their own well and providing their own source of water. So that's why it's such a small 1%, even though it's considered domestic. A lot of the people who would be domestic are categorized under the public supply if it comes from a water authority or something like that. 31% is that irrigation. That's a large percentage of our water, you see. Agriculture and horticulture are the two biggest draws when they talk about irrigation needs. And it should be noted that most of that water that is used for irrigation is done so by 17 western states. So we really need very little irrigation on the East Coast, but those western states with very little water have a large amount of irrigation needs. Livestock, even though it's on the graph as 1%, it's actually less than 1%, and this is to care for water needs for any livestock. Feedlots are large regions that have a lot of cattle or pork or chickens, things like that, when there's almost like an industrial type setting for livestock growth, and then dairy operations. Aquaculture is fish farming, essentially. If you go to the store and you purchase fish, a lot of times it's required to give its origin, and it might say that it is farmed fish and what country it's from also. So this is actually a really growing industry as we are eating more and more fish in the United States. There's more and more fish farms to produce the fish that we need, and that's increase of demand, but also because of decrease of the supply in the oceans. Industrial is 4% of the total. This would be anything from manufacturing food, paper, chemicals, and this is water that is not included in that public supply area. This is where the industry itself obtains water. So maybe they have a plant that's located along a river or a lake, and they draw in the water at that surface from that surface water, or they have their own well system from on site. Mining is metal extraction, petroleum and natural gas as well. In this region, we hear a lot of talk about the Marcellus gas wells. They do use an extensive amount of water in the drilling and production from that natural gas, so that also in this region in Pennsylvania and western Pennsylvania, that percentage is probably on the increase. And then finally, the last category, the biggest category, is thermoelectric power. If you don't know much about power generation, this is a typical coal-burning power plant. You can see the stockpiles of coal over here in the background. They've got here the big smokestacks. This is where they would actually be burning the coal, and these really tall smokestacks are where the exhaust from the burning of that coal would go up here. So this may or may not contain different amounts of pollutants, depending on what kind of technology they have at the plant. But where most of the water is actually used in this is right here in these two devices here. These are known as cooling towers. And here's another picture of those at a nuclear power plant. A nuclear power plant, this is a little domed building, is actually where the nuclear reaction is going on. In both of these, the basic idea is that there is water throughout the entire system. The water is heated by the heat given off in the chemical reactions, whether that's the burning of coal or the nuclear reaction giving off heat. Water is heated, it makes steam, that steam turns a turbine, the spinning of that turbine makes electricity. That water, though, once it's heated, it needs cooled down again, and that's what these big towers are known as cooling towers, and they have a big honeycomb structure through them, and the water just kind of tumbles down through this big honeycomb, and as it does, it cools, and then it condenses again, and that's why you see a large amount of, and this is just pure water vapor. There's nothing in this at all. There's no smoke, anything like that. It's just pure water vapor coming down or out of those cooling towers. Most of the water, as it cools, it just descends down through here and is put back into the piping system again for the whole process to start over again. The top water use in the U.S. by states are California, Texas, Florida, New York, and Idaho. Those are the top 5 states in terms of the quantity of water they use, and you can see beside them I've written why they use them. Irrigation number 1 and power number 2 in California. Reverse that for Texas, power number 1, irrigation number 2. Florida and New York for power generation, and Idaho, surprisingly, for irrigation. I guess you got to get your potatoes from somewhere, right? You can see that power is very important, but also keep in mind why it's important, because California, Texas, Florida, New York, some of the most populated states, so they have a large population, so they're going to have a higher need for power. Idaho, less population, but lots and lots of farmland and rather dry conditions in Idaho, so they need irrigation as well. In Pennsylvania, most of our water is used for power and for the public water supply. A couple areas of concern in the U.S. First is the Ogallala Aquifer depletion. This is that aquifer that stretches throughout the central United States from South Dakota all the way to Texas. And as you perhaps have seen in some of your workbook activities, that this is an area of great concern because the withdrawal rate is much greater than the replenishment rate, and so that's a concern. Another area of concern is the West Coast drought. Again, just multiple years of below average precipitation, and that area has been under a severe drought for several years now. We shouldn't neglect our own local water problems, and this is actually kind of a water problem for most of the older cities, industrialized eastern coast of the U.S., and that is our water infrastructure. A lot of the pipes that would have been in place have been in place for now even upwards of 100 years. And this is really across the country where we're seeing this issue. A lot of those pipes are bursting, and when they burst, it puts a lot of pressure underneath the ground. We get sinkholes forming. Water lines are actually filled with sediment, corrosion, things like that. So replacing these is going to be a big expense, and is a big area of concern for many locations around the country. Next, we'll turn our attention to global water use, and you can see here some of the top countries that use water: United States, India, and China, along with Russia and Brazil, and those are the top 5 highest consumption rates of water. Is significantly different, though, than the highest per capita rates, and that would be led by the United States, Australia, Italy, Japan, and Mexico. So why do countries use the amount of water that they do? One reason is that industrial countries are often said to export water. They're industrial, so they make a lot of food, they make a lot of products, and when they make a lot of products and then export those products, the water that was used to make those products is also considered part of the, they call it virtual water, that is carried along with that product. High populated countries that don't have much land or very little water are often considered water importers. So with that in mind, you can kind of think about the countries that would be the top exporters of water. A large country like India, a very pretty industrialized country like Argentina, with a lot of water supply. The US, Australia, and Brazil are the top exporters of water. And think about how small these countries are that are the top importers: Japan, Mexico, Italy, Germany, and the UK as being countries that get a lot of water brought into them. Another area of concern globally is actually just getting water when you need it. We're pretty spoiled in the US. We go to the tap, turn the water on, it's right there. But in many other regions of the undeveloped world, it's a concern to go and just get water from whatever source it might be. And you may have to walk miles to get that water. And we see that by this chart that primarily that is the role of women in most cultures to gather water. And it's especially predominantly more so in Africa, where you can see in Africa, by the time you count women and girls, it's 91% is a female job to 81% to gather water. And again, they have to travel great distances to get water, so that is a serious issue. And what it tends to lead to is women being able to have less opportunity for education, for a good life, things like that. And I think it's ironic. We see like a very traditional water carrying vessel here, but then we also see that they've got still adding our own Western influence of plastic jugs, etc. Globally, what do we use most of the water for? It's mostly for agriculture. So 92% of the water is for agriculture. Of that 92%, as part of that 92%, 27% of the total water use is for grains, wheat, rice, and corn, 22% for meat, and 7% for dairy. So you can see that it is a quite different picture globally versus the US, and that you should keep in mind what are some of the differences between global water use and water use in the US.